Well, guys, to finish off Chapter 6, we're doing Part 2 of 6.6. We looked at yesterday, or the previous lesson was 3 different operations, right? We multiplied, we divided, and we used exponents on our z values. And so what we're looking at in the final one here is really just one idea that we're going to go through, which is now finding roots of our z values. So the example we're going to go through first looks like this. So here is our z value. Notice it's in trig form, so r cosine theta plus I sine theta, just like we talked about in the previous lesson. And they're essentially asking us for the fourth root of this big number here, the fourth root of z. So here's what this looks like, and a lot going on in this, so take a look. I wanted you to see the formula on the top of page 501 in your book. Looks like this. So here's what we're doing. So here's the initial problem that we are getting, and they are asking us for an nth root. In the one that we are looking at, it is the fourth root, right? So n is 4. So that's why when you see the formula, we're doing the fourth root of whatever r is. I'm also going to have a 4 here and a 4 here within my setup. One thing to recognize is whatever root you are taking, that's how many values you're going to come up with. So when it says find the fourth root, we need 4 results to show those 4 roots. What you're seeing right here is really mostly a reminder that theta gets repeated every time you take a lap around the circle, right? So if I have my theta, my angle, well, if I add 2 pi to that, remember, I'm just getting another answer by taking another lap around the circle, right? So I could add 2 pi 0 times if k was 0, and that just gives me the initial value. I could add 2 pi once if k is 1, and that takes me 1 lap around the circle to give me my second answer. If k is 2, then I would be adding 4 pi to my answer, so it's like taking my initial value and adding 2 laps around the circle. Or if k is 3, I'm adding 3 laps around the circle. If k is 4, I'm doing 4 laps around the circle on top of the initial answer. So here's what I want you to see on that is if I'm going to take a fourth root, then this is what I'm going to consider, right? I want the initial value where k is 0, but then I'm going to add as 1 is k, 2 is k, and 3 is k. So another lap around the circle, another lap, and then another lap around the circle. So I'm getting a total of 4 results on this, because I'm first going to treat k as 0 and just get my initial value, but then I'm going to take 3 more laps around the circle to get 3 more answers. Since this is a fourth root, I want 4 results. So hopefully that makes sense, but that's what's going on within the setup that you see here. So again, that's on page 501, so you can refer back to this for some guidance if you need it, but let's go through a full example together, and then we're going to do some practice on our own. So don't worry, we're going to get plenty of practice on this. I think that's a little more clear. So here was the initial problem. Guys, do notice that this is in trig form, and so if you were given something in standard form, you would have to convert it into this form first, and that's what we learned in our previous lesson, right, before you start working with the formula. So they said the 4 roots of this. So 2 cosine 2 pi over 3 plus I sine 2 pi over 3. So again, notice they started with the fourth root of r, and that's what we saw in the formula on page 501. That's what goes on the outside. So the fourth root of r. On the inside, again, it's a fourth root, so my n is 4. That goes here and here. So this is the initial setup that we're working with. So before I start coming up with my 4 z values and plugging in numbers for k, because we're going to be plugging in 0, 1, 2, and 3, right here, just like we talked about a minute ago. They said before you start plugging in those numbers, let's just recognize what we really have if I clean this up first. Right? So what if I took these numbers and divided each one of those or reduced them by 4 before we even start? Okay, so if I did 2 pi over 3 divided by 4, I get this. And if I did 2 pi k over 4, I get this. So they're just simplifying this fraction first before they start plugging in values for k. And so from here, it's as ugly as it looks. It's really not that bad because we're just plugging in numbers into this formula that we have. So this is now the angle that we are working with. And so here's my 4th root of r. I'm going to do the cosine of, and I'm going to take my initial value and plug in a 0 for k. And that's going to give me this look right here. That's going to be the initial angle. They did that for cosine and sine. And they're just getting this look right here. So there's our first root, the first z value. Then I'm going to take this angle and plug in a 1 for k. And it's going to look like this. And if you combine your fractions, we get that look right here. Then they're going to plug in a 2 for k to get this answer, and then a 3 for k and get this answer. So as ugly as it looks at first glance, you guys will see it's really not that bad, just maybe a little tedious, especially if we're kind of writing all this stuff out multiple times. So let's go through 2 of these together, and this will finish off the chapter for us. So we're going to be doing these guys on another page, so I have that. If you're taking your own notes, you can do this on your own piece of paper somewhere. So we're going to start with this one, because this one is going to be more similar to what we just did. Then I'll do number 21 to end it. So they want us, in this case, to take the cube root of our z value. So again, guys, notice on this is in standard form. So before we take the cube root of z, we have to put it in terms of z, trig form. So did this in our previous lesson, so I'll go through this pretty quick. We know to get r, we use Pythagorean theorem. So if I did a squared plus b squared, so a squared would be 3 over 4, plus b squared would be 1 over 4, which is 4 over 4, which is 1, so r is 1. Nice easy value for r on this one. We're going to get theta by doing the inverse tangent of b over a, so negative 1/2 divided by rad 3 over 2. So where are we going to see that on our unit circle? And guys, again, keep in mind what quadrant we are in. This would go right, then down, so I'm in quadrant 4. So where am I going to see a tangent ratio where I'm doing this y value divided by this x value? So negative 1/2 divided by rad 3 over 2 in quadrant 4. So negative 1/2 divided by rad 3 over 2, right? This is y over x. That's how we get tangent. So I know I'm looking at this angle right here, which is 11 pi over 6. So there's our angle for theta. So let's put that together. We know that z is r cosine theta plus I sine theta. And no, you do not need the 1 in front. I just wanted to remind you where that goes, but you could certainly do without it. Okay, now that we have this in terms of z, now we can take the cube root of z, which, remember, if it's a cube root, I should be coming out with 3 roots, right? So that tells you how many values we want to be coming out with. So we have our setup here. Again, I'm going to follow this model. So I'm going to start out by putting the cube root of r, which is the cube root of 1, which you don't really have to write that. I'm going to write it just because I want you guys to see where everything is going. So I got the cube root of 1, which is 1, which is really not going to change anything. And then behind that in parentheses, I'm going to do the cosine of theta, which we just figured out was 11 pi over 6, plus 2 pi k over 3. So we're going to say cosine of 11 pi over 6 plus 2 pi k all over 3. Since we're doing a cube root. Same thing for this guy. So before we start plugging in our numbers for k, which, again, keep in mind on this, we're going to be using 0, 1, and 2 in order to get the 3 results, right? So we always start with 0, and then you work your way up until you have this many values, right? So 0, 1, and 2 are going to give us the 3 roots that we're looking for. So on this one, again, they might clean this up a little bit before you start plugging in numbers for k, but you don't have to do that. That's just a way of maybe saving you some work as we go through. So they might say, as far as the angle goes, so I could reduce this right here to be 11 pi over 18. And that would just stay 2/3 or 2 pi over 3k. So we're going to be using that. We're also going to be using the same thing with sine. This will reduce the same way, 11 pi over 18. Plus 2/3. Okay. So here's the setup, and now I've gotten this far, really the hard part's over, because now all I have to do is plug in some numbers. So if n equals 3, then we're going to use 0, 1, and 2 for k to get our 3 roots. And we always start with 0 because I want the initial angle. I don't want to take any laps around the circle yet, so I'm going to plug in a 0 for k to zero this out, and so it's just the cosine of 11 pi over 18. Here's my first one. Same thing is going to happen over here. And so there's our first root. And that was when we plugged in a 0. In fact, I'll just write this here so we remember where it all came from. So if I said k equals 1, then I'm going to get my second root. So now I'm going to plug in a 1 for k. So now I'm going to do 11/18 plus 2/3. So let's see, if we did some common denominators, times 6, so 12 over 18. So 23 over 18. So there's our second root, and to get our third root, we're going to plug in a 2 for k, meaning we're taking like 2 laps around the circle to get our third root here. So for the third one, we've plugged in a 2 for k, so this is now going to be 4 pi over 3. So let's see, times 6, so 24 plus 11 is going to give us 35 over 18. And that's it. So these z1, 2, and 3 represent the 3 roots that we're getting from this z value. So for this one, same question. What I wanted to show you on this one, though, is notice this is just a real number. There's no imaginary number. So they call this a number of unity. It was a perfect root. There was no negatives. So there's no imaginary portion of this. But if I still want to carry out the process that we just did from the previous one, I still have to put it in terms of z and then go through that formula. So for a case like this, I know that -1 is my real number, and I had a 0 for my imaginary. So I'm first just putting it in terms of standard form. Sorry, I should not have written z because that's not in z form. That's standard form. But I need to convert that to terms of z. And so in our z form, we know we find our r value with Pythagorean theorem, a squared plus b squared. So our r value is 1. I can get my angle, my theta, by doing the inverse tangent of b over a, which would just be 0. So what tangent has a 0 value? What tangent ratio? And so if you look at our unit circle, so tangent where it would be 0, is any time I'm at either this guy or this guy, right? Because 0 divided by 1 is 0, 0 divided by negative 1 is 0. So which angle are we using? Are we using 0 or pi? Well, in this case, this one is going left 1, so I'm at pi. So now I could write this in terms of z, which would be r, and again, you don't need the 1, but I'm just going to put it for the sake of notes, cosine theta plus I sine theta. So now it looks like this in terms of z. Now I could go through the process that we were just doing, right? If I did want 5 roots on this, so again, I would start out by taking the 5th root of z, which is, or sorry, the 5th root of r, which is just going to be 1. So again, you really wouldn't have to write that, but I'm just putting that there for you for the sake of notes. And then I got the cosine of, so I got theta plus 2 pi k over n, which in this case is 5. So there's our setup. So now I'm going to find my 5 roots by plugging in 0, 1, 2, 3, and 4 for k. So keep an eye on this one, because I do want you to see that this one, because of the angle we're working with, we can simplify it a little further. So let's start by plugging in a 0 to get z1. So if I did plug in a 0 for this, I'm just going to get the cosine of pi over 5. Piece of cake. Let's plug in a 1 for k to get our second root. So if you plug in a 1 right there, pi plus 2 pi is 3 pi over 5. So to get my third root, I'm now going to plug in a 2 for k, so this is going to be pi plus 4 pi over 5, which is 5 pi over 5, which is just pi. And then we can keep going. Guys, you might notice a pattern on this: 1/5, 3/5, 5/5, 7/5, 9/5. So you might start recognizing that some of those patterns, and then that'll save you some time if you can kind of recognize those. So I'm not going to fill those out, but you guys get the idea. So this is going to become 7 pi over 5 and 9 pi over 5. And we are going to leave them in this form because the directions did say to leave your answers in trig form. So we're going to leave them as they are, and that is the end of Chapter 6.